In this example, we're going to divide decimals with terminating decimal quotients using fractions. So our final answer isn't going to be a whole number like it was in the last example. We could have decimal answers too. And we're going to use fractions to aid us in finding the result and rewriting it as a decimal. So we're building up the ideas of why our eventual decimal dividing process, which is an algorithm and pretty straightforward, and the easiest way to do it is making sense. So we're trying to look for patterns and gain ideas so we understand why that algorithm makes sense. So let's look at the first problem. We have 12 hundredths divided by 3/10. So we want to start by rewrite the problem using a common unit fraction. So right now 12 hundredths and 3/10, we're saying this in hundredths and this in tenths. So what I'm going to do is add a 0 to the 3/10. Okay, so you usually have to extend to whatever the smallest decimal place is. And I'm going to rewrite it like this. So this is 12 hundredths divided by 30 hundredths. Okay, so now they have a common unit fraction. Okay, so now let's think of this in copies of language. This is asking how many copies of 30 hundredths are in 12 hundredths. Okay. So this language can start to get confusing with division when our answer is going to be less than 1, because you may have been tempted to reverse the 30 and the 20. Okay, the 30 is the divisor. We're asking how many copies of size 30 hundredths are in 12 hundredths. And that number is going to be less than 1 because 30 is less than 12. Okay, so it's tempting to try to divide the larger number by the smaller number, but that's not always the case. Sometimes we're doing the reverse, and that's what decimals and fractions are all about. Now, we saw in the last video, we're going to rewrite this in an equivalent form in copies of language. So I'll write this is equivalent to. Okay. So remember, if we have the same unit fractions, then we don't really need to consider the unit. We can just think of these as ones. So this is equivalent to how many copies of 30 are in 12. Okay. So again, thinking back to the last video, we could look at 12 yellow squares and see how many 30 yellow squares are in it. Okay. Or we could look at 12 ones and see how many 30 ones are in it. And again, I know that number's less than 1. But once you have that common unit fraction, these are equivalent. You don't need to be concerned with the fraction size. Okay. So now we're going to rewrite this as a fraction and simplify. So we're going to use this statement right here. It's going to make our work a lot easier. How many copies of 30 are in 12? Well, that's equivalent to basically this statement, but just leave out the hundredths. So we have 20 divided by 30. Okay. And as a fraction, that is 12 over 30. Okay. So this is this quotient, this division problem, written as a fraction. Okay, so it is the quotient, it's our answer. Okay, but we're going to simplify it and then convert it into a decimal using methods we learned in Unit 3. So I happen to know the greatest common factor of these two numbers is 6, so you can start by dividing by 2 if you want. But if you see a larger common factor, it'll save you a couple of steps, or at least one step. So 12 divided by 6 is 2. 30 divided by 6 is 5. Okay. So this fraction is completely simplified because the numerator and denominator don't share any common factors besides 1. Okay. So just reflecting back on the question, this means there is 2/5 of a copy of 30 hundredths in 12 hundredths. Now, typically, when our problems start with decimals, we want to answer them in decimals. Also, you'll see later if our problems start with fractions, we want our answers to be fractions. So I'm going to take this fraction and convert it to a decimal. And notice this is one of the nice ones. This is a terminating decimal, and I know that because the denominator can be written as only a factor of 2's and 5's. In this case, we just have 1 5. So that tells me that I'll be able to write this as a decimal with a power of 10 in the denominator. So since I have one factor of 5, I would need to multiply that by a 2 to get 10 in the denominator. And whatever I do the denominator, I'm going to do that to the numerator. And multiplying across, this is 4/10. Okay, and we know to write that as a decimal, we put 4 in the tenths place. So we have 0.4. Okay. So 12 hundredths divided by 3/10 is 4/10. Okay. Now, notice this was a lot of work. Okay, but again, we're trying to develop these ideas. And remember, in the last example, we did a few different division problems, all involving 12 and 3, either hundredths or tenths. Okay, and we got answers of 4. And here we have an answer of 0.4 or 0.4 or 4/10. And that's not a coincidence, and we're going to use this idea in the next video to come up with a general strategy so we don't have to go through as many steps. But again, make sure you review and understand this process so you know why the steps are going to work. We're going to look at one more in this manner and see if our pattern holds. So here we have 12 hundredths divided by 3. Okay, so I'm going to write that with a common unit fraction. So I'm going to need to go out to the hundredth spot. So we would say that this is 12 hundredths divided by, well, 3 is equivalent to 300 hundredths. Okay. In copies of language, we're asking how many 300 hundredths, that's a mouthful, are in 12 hundredths. How many copies of 300 hundredths are in 12 hundredths? And since we have this written with a common unit fraction, remember this is equivalent to the easier division problem of how many copies of 300 are in 12. Okay. So looking back at our division problem up here, since the unit fractions are the same, we can eliminate them and think of this as the problem 12 divided by 300. So let's rewrite this as a fraction and simplify. Well, 12 divided by 300 as a fraction is 12 over 300. Okay. Now we want to simplify this. So I'm going to start with the same common factor we used last time, 6. 300 divided by 6. So 12 divided by 6 is 2. 300 divided by 6 is 50. So notice this isn't completely simplified, and that's fine. They actually had a greatest common factor of 12. So I'll divide by 2 one more time. They were both even. That's how I knew that. And we get 1/25. Okay. So there's 1/25 of a copy of 300 hundredths in 12 hundredths. So now let's convert this to a decimal. Well, 1/25, that's the same as 1/5 times 5. So to make this a power of 10, we're going to need 2 factors of 2 to match up with the 2 factors of 5. Times 2 times 2, and we'll also do that to the top. Multiplying across, we have 4, and on the bottom we have 10 times 10 is 100. So we have 4 hundredths, which we know is a decimal, is written with a 4 in the hundredths place. Okay. So notice again, with all of this, we ended up with an answer involving 4. So 12 divided by 3 is 4, and what varies is where the decimal point is going to be placed in the final result.